Perceptual load theory and inattentional blindness are important concepts that explain how our brains process and interpret information and environmental stimuli. Perceptual load theory relates directly to the idea that the brain has a limited attentional capacity and suggests that the processing of additional information, which is irrelevant to the task at hand, can be prevented depending on the load or the demand that it places on attention. Specifically, a higher perceptual load correlates directly with a large amount of information being processed at one time, leaving little spare attentional capacity to process additional information. However, in situations with low perceptual load, there are greater attentional resources not being used, leaving individuals more susceptible to distraction from the primary task. The second concept is inattentional blindness, which is a situation where one fails to notice something within view because their attentional resources are preoccupied elsewhere. In many experiments testing inattentional blindness, those who fail to notice the object appear to look at it just as much as those who do. This highlights that it is not that we fail to see it, but we fail to recognize that the object is there. An understanding of both of these concepts has significant implications for driving. As demonstrated in the studied article by Murphy and Green, inattentional blindness can explain different phenomena applicable to the road, such as a driver's inability to see a pedestrian, and how this is directly influenced by perceptual load. An understanding of these processes in the brain can facilitate the implementation of road safety procedures, signs, and even laws that can promote a safer road for drivers and pedestrians.
The experiment by Murphy and Green attempts to examine the effects of perceptual load theory and inattentional blindness on the driver's awareness of a pedestrian in their peripheral view. For this experiment, 42 experienced drivers were recruited, with all participants having been driving for an average of 5.7 years with a standard deviation of 4.8. Individuals were required to participate in an experimental drive, where they were given access to vehicle controls such as gears, pedals, and speedometers. To become accustomed to the simulation and controls, all participants were given a 10-minute practice drive. 20 practice trials were completed before conducting 70 experimental trials. In the experimental trials, there were many gap perception tasks along the road, where 3 vehicles on either side of the road appeared in front of the car. Participants were to judge whether or not they could indicate left and fit into the gap or pass around the vehicles to the right because the gap was too tight. However, on trial number 35 and 70, there was an unfamiliar object such as a pedestrian or an animal on the side of the road, as seen in figure 1 on the screen. At the end of these 2 trials, participants were asked if they had noticed anything. As this experiment was testing perceptual load theory, the trials were randomly categorized as low load or high load tasks, where the gaps between the vehicles were much larger and easier to differentiate in the low load trials than the high load trials.
The results of this study constitute empirical evidence for perceptual load theory impacting driver behavior and awareness. On average, drivers responded quicker in low load than high load trials, 993 milliseconds and 1,129 milliseconds respectively. While participants made few errors in both conditions, low load trials on average warranted more accurate responses to the gap perception task than the high load trials, 98.6% and 97.8% accuracy respectively. This is because in the low load trial, the car could more obviously fit in the gap, warranting higher accuracy in results for this condition. Collisions with parked vehicles also occurred more in gap perception trials with high load than of low load because it was harder to judge the gap, the mean being 1.36 and 0.14 crashes respectively. The most important finding of the experiment was the substantial difference in intentional blindness levels between conditions. As demonstrated in Figure 2, 53% of drivers reported awareness of the central stimulus under low-load conditions and merely 17% under high-load conditions. The significant difference in participants' awareness of the pedestrian in the high-load trials demonstrates that when their focus or attention was in high demand from the task at hand, they were more likely to fail to see the central stimulus.
The results of the study mentioned provide tangible evidence for the implications of perceptual load on inattentional blindness in the applied context. The study holds reliability as experimenters conducted 20 practice trials and 70 experimental trials for each of the participants. The repeated tests ensure that outlier results do not have a significant impact on the final results, making them credible. Furthermore, the premise of the study, where participants have been placed in a driving simulation, is significant as results ascertained can allow perceptual load theory to be considered in a real-world context, where attention is crucial to driving performance and safety. However, the study is not without limitations. It is important to consider that the study has a limited sample size of only 42 participants. Such a small sample size means that individual characteristics and skills perhaps may play a part in the final outcomes, rather than the attentional processes alone. This also means there is limited generalizability due to the use of a sample of participants from a specific population. As mentioned in the article, these participants, being from the same area, may be familiar with the situation depicted in the road simulation. This could have put the sample at an advantage. For example, participants could be familiar with driving on small roads and thus be better at estimating relative distances in the task. Whilst this may account for some of the accuracy demonstrated by participants in the trials, it also has the potential to limit the implications of the results. Testing participants on unfamiliar roads and in different driving contexts would have been more effective in varying the perceptual load and attentional demands. Ultimately, the study has provided reliable results, and its outcomes could be utilized to ensure road safety in a wide range of contexts. But further tests into different demographics may prove useful to more accurately represent the general population.
Existing literature exploring perceptual load theory and inattentional blindness are primarily focused on laboratory studies, and those that attempt to apply such models require further research. As discussed in the evaluation, the article by Murphy and Green is limited in that its sample size is small. Our proposed study first aims to address the limitation of low generalizability due to geographical restrictions through conducting a cross-cultural replication. Such a replication will involve manipulating conditions such as road size and road conditions to remove the possibility of familiarity improving participants' performance in the task. To further increase generalizability and reliability, the proposed study will increase the sample size from 42 to 500 participants. By acquiring a larger and more diverse sample, the results will be less influenced by individual differences, such as variations in decision-making abilities or attention spans. Moreover, this allows for the consideration of other relevant variables, like age, gender, and cultural variations, providing a more comprehensive understanding of the results. As a result of this, the findings will be more generalizable and representative of the overall population's performance.
Secondly, in the present study, participants conducted 70 consecutive trials following 20 practice trials, all of which were similar in length and completed without breaks on the same road simulation. This, however, fails to accurately represent real-life driving conditions, where there are many instances in the real world where people may have to drive for longer periods of time and in varying road conditions. Such long drives may potentially enable for the effects of fatigue to impact attention and awareness on top of varying perceptual load situations. Therefore, while simultaneously broadening the sample size and the demographics of participants, the proposed study will implement a 2x2 factorial design. The primary focus of the task will still be the gap perception task, as in the present study. However, there will be two independent variables influencing the task, which are perceptual load, either high or low, and the duration of the study, either with or without breaks in between trials. This additional variable will enable us to more accurately stimulate the complexities of driving in the real world, namely that of fatigue and perceptual load. These can significantly impact attention, awareness, and the driver's ability to perceive and respond to potential hazards. This notably improves the ecological validity of the experiment, where the results would be more representative of real-life driving situations, as there are many instances where people have to drive for longer periods of time and in different road conditions. Such an improvement in this research field extends some important implications to not only the understanding of road safety, but implications for legislation and guidelines, as well as road and car designs. For example, if inattentional blindness is worsened when participants are driving for longer periods without brakes, it may indicate the need for an improvement in road safety legislation regarding the maximum time that one can drive at a time.